Hi folks, welcome back. I hope you're all doing well. I'll confess that I first came across this paper because I wrote a blog post with a similar title not so long ago. But the idea in this paper is a bit different. The authors over here are proposing a new prompting method for large language models to solve problems that are heavy on reasoning. And their prompting method is a variation on chain of thought or program of thought, and they call it think and execute. Let's try to place this in context. By now, most people are familiar with the very popular chain of thought prompting method, which asks LLMs to solve a problem by first spelling out a series of steps that it must take to solve that problem, rather than asking for the solution outright. A very popular variation on chain of thought is what is known as program of thought, where the idea is to ask the LLM to write code to solve the problem rather than to solve the problem itself. And then you would execute the code to get the solution to the problem. What the authors in this paper are proposing is a two-step prompting approach that they call think and execute, where in step one, which is think, they ask the LLM to first come up with a general solution to the problem. And in that sense, it's very similar to chain of thought. The crucial difference being that we ask the LLM to come up with that solution as pseudocode rather than plain English language. So this lies somewhere in between chain of thought and program of thought. Chain of thought is just prose, plain language. Program of thought is actual executable code. And this lies somewhere in between, where you ask the LLM to generate pseudocode, which is not executable, but is a bit more precise than just plain English language. So that's step one, which is the think step. And in the second step, execute, you apply that generic pseudocode solution to a specific instance of the problem you're trying to solve. This diagram shows the process in a bit more detail. Like we said, in step one, we ask the LLM, given a few examples of the task it is being asked to solve, to come up with a generic pseudocode description of the solution. And in step two, which is the execute step, you apply that to a specific instance of the problem. And you could use different models for each of these steps. The model used for the think step is called the Instructor model, and the model used for the execute step is called the Reasoner model. And this interesting division of labor allows a neat optimization. If you look at these steps, the think step is the harder step. And so you'd want to use a more capable LLM, something like GPT 3.5 or beyond, for the think phase. But once you have this pseudocode description, you can actually use a smaller model, something like a Llama 17B or even a 7B model, to run the execute step and still get problem-solving rates that are comparable to other much larger models without think and execute. I'd encourage you to read the full paper, but they do have the full prompts in the appendix. And if you look at the think prompt, which proceeds in a couple of steps, in the first step, you ask the Instructor LLM to generate an explanation or an analysis. And this is a few short prompt. You're given a few examples of the problem description and solution, and the output is an explanation. And then in the second step of the thinking phase, you ask the LLM to take that analysis and write it out as pseudocode. And then in the execute phase, you take that pseudocode and try to apply it to get an answer. So let's look at what results they got. As they say over here, the heavy lifting for the Instructor model is done by GPT 3.5, but then they vary what the Reasoner model could be. and see what the results are like. So they've used a 7B model, a 13B model, and GPT 3.5 itself as the reasoner model. They're trying this out on a number of problems from Big Bench, and these are all reasoning heavy problems. Things like Dyke languages, geometric shapes, navigation, reasoning over colored objects. So these are all like logic puzzles. The thing to note over here is once you've used GPT 3.5 to come up with the pseudocode, that's the think part of think and execute. Even if you use a smaller model like Llama 13B, in this case, they're using Code Llama 13B. If you look at its average solution rate over here, it's similar to GPT 3.5 with direct or zero-shot prompting. So that's an interesting optimization because you can do the think phase once with a heavy LLM, but then apply that analysis to solve many instances of that problem with a much lighter model. Another interesting thing to note here is that using a code pre-trained model like Code Llama instead of plain Llama for the execute phase gives you much better solution rates. So even though you're not actually asking the model to generate code, a code-trained model performs much better. One last interesting comparison from the paper is that they asked humans to write this pseudocode for various problems. So the pseudocode is the output of the think phase. And they compared the solution rates of human-written pseudocode with pseudocode produced by the think step of think and execute. And actually, the think and execute pseudocode had a higher success rate than the human-written pseudocode, which is an interesting result. So that's a quick look at a paper which is proposing a variation of chain of thought and program of thought called Think and Execute that uses pseudocode rather than executable code and achieves some decent solution rates on reasoning heavy problems, even with smaller models used for the reasoning. I hope you enjoyed that. If you like videos like this, please consider subscribing, like the video, and I will see you next time. Thank you very much.